Hello everyone. Team-1 is here to present before you surface hardening methods. Team members are myself, Abhijit Jitesh, Abhinand Rajesh, Adit Ajay, Ashin Binoy, and Abhinav Mukundan. The presentation covers all these topics, which are surface hardening, case hardening, carburizing, nitriding, carbon nitriding, cyaniding, selective surface hardening, and induction hardening. Surface hardening. Heat or mechanical treatment of steel to improve the hardness of the outside surface while leaving the core relatively soft. The combination of a hard exterior and a soft interior is highly prized in modern engineering because it can endure extremely high stress and fatigue, which is important in gears and anti-friction bearings. Surface hardened steel is highly prized for its low cost and manufacturing flexibility. Surface hardening methods. Numerous industrial applications demand that a component possesses different or even contradicting properties for the surface and the interior. For example, components that usually require surface hardening include gears, bearings, valves, cams, hand tools, rolls, shafts, machine tools, bearing races. All these service conditions of many components require a hard wear resistant surface and a tough shock resistant interior. Storage tanks and chemical processing equipments need a surface to resist corrosion, chemical attack together. With enough strength and low cost, decorative fittings, home appliances, etc. All these require a good surface finish and appearance, together with adequate strength and low cost. Surface hardening techniques can be classified into two major categories: processes that change the surface chemical composition, that is, case hardening, and processes that do not change the surface chemical composition, that is, selective surface hardening. Case hardening, also known as surface hardening, is the process of hardening a metal's object surface while leaving the metal deeper down soft, resulting in a thin layer of tougher metal at the surface. The case hardening method includes injecting extra carbon or nitrogen into the surface layer of iron or steel with low carbon content, which has poor to no hardenability on its own. Case hardening is often done after the items has been formed into its final shape, but it can also be done to increase the hardening element content of bars for pattern welding or other related processes. The different types of case hardening methods are carburizing, nitriding, carbonitriding, and cyaniding. Now I hand over the mic to Abhinand Rajesh. Thank you.
Hi all. As Abhijit has mentioned, there are mainly four case hardening methods. Number one is carburizing. Carburizing is a thermochemical process in which carbon is diffused into the surface of low carbon steels to increase the carbon content to sufficient levels so that the surface will respond to heat treatment and produce a much more harder wear resistant layer. This is done by heating the steel in contact with a substance that has higher carbon content. The steel is heated at a temperature between 850 to 900 degrees Celsius for a suitable period of time. The benefits of carburizing is that it imparts a hard surface, improving wear resistance as well as increased fatigue strength. Method 2 is nitriding. Nitriding is a heat treating process which diffuses nitrogen into the surface of a metal to create a case hardened surface. The process is that the steel piece is heated in a furnace between 500 to 600 degrees Celsius and it is exposed to the ammonia gas at the same time. The heat from this furnace causes the ammonia to decompose into hydrogen and nitrogen. This is the process of nitriding. Nitriding is most commonly used on low alloy steels. The benefits of nitriding is that it increases the abrasion and wear resistance and improves the bending and contact fatigue properties of the steel. Nitriding times usually range between 1 to 1000 hours depending on the composition of steel and the depth of hardening we require. Method 3 is carbonitriding. Carbonitriding is a process in which atoms of carbon and nitrogen diffuses interstitially to the metal, creating barriers to slip and thereby increasing the hardness and modulus near the surface. When compared to carburizing, carbonitriding gives better hardness to the surface. This is because along with carbon, nitrogen atoms are also diffused to the metal. Carbonitriding is performed at a temperature between 700 to 800 degrees Celsius. In this method, quenching is also done. Quenching is a process in which the metal is rapidly cooled in water to obtain certain material properties. But in carbonitriding, we do not require a severe quenching method like water quench. So we here do quenching using gas. The result is a less distortion on the material to be treated. Thank you.
Hello everyone. Today we are going to discuss about a process called cyaniding. So these are the contents that we are going to see during this presentation. So what is cyaniding? Cyaniding is a case hardening process that is fast and efficient. It is mainly used on low carbon steels where the steel part is heated to 871 to 954 degrees Celsius in a bath of sodium cyanide and is quenched and rinsed in water or oil to remove any residual cyanide. The process of cyaniding. During the process, the steel part is heated to 1600 to 1750 degree Fahrenheit in a bath of sodium cyanide, and it is quenched and rinsed in water or oil to remove any residual cyanide. The reaction occurring during this process are as follows. First, the sodium cyanide combines with oxygen molecule to form sodium cyanate. The sodium cyanate again combines with oxygen molecule to produce sodium carbonate, carbon monoxide, and nitrogen molecule. The carbon monoxide obtained from the above reaction splits into carbon dioxide plus gas. This process produces a thin hard shell between 0.25 to 0.75 and can be completed in 20 to 30 minutes. It is typically used on small parts such as bolts, nuts, screws, and small gears. The advantages of using cyaniding process. It gives rapid heat transfer. It produces only low distortion to the steel, negligible oxidization or decarburization of surface. It gives uniform depth. It is less time consuming, rapid absorption of carbon and nitrogen, and it also provides a bright finish to the machine parts. The main disadvantages of using cyaniding process are cyanide salts are really poisonous. If it enters our bloodstreams, it deprives our blood cells from receiving oxygen and it automatically leads to malfunction of our heart or brain damage. Cyanide attacks wounds. Even fumes can cause damage. The direct contact could be really harmful. Molten cyanide explodes on contact with water. So these are some images of cyaniding plant. So these are the type of materials that undergoes this process. Thank you.
So I am Abhinav Mugundan. So the next surface hardening technique which are commonly used is induction to hardening. We are mainly going through its introduction, history, tampering, methods of hardening, application of hardening, etc. So the hardening is the process in which the steel is heated towards a temperature above the critical point and held at this temperature and is quenched quickly in water, oil and molten salt bath. The types of hardening are quench hardening, work hardening, precipitation hardening, surface hardening, etc. The types of surface hardening are flame hardening, induction hardening, carburizing, cyaniding, nitriding, and carbon nitriding, etc. So, the induction hardening is a form of heat treatment in which the metal parts heated by induction heating and then it is frequently quenched. The material is heated by passing the current that generate alternating magnetic field resistant lead to the heating of the metal. And as we look at its history, the basis of all the induction heating system was discovered in 1831 by none other than Michael Faraday. The Faraday proved that a winding of two coils possible to create a momentary electromotive force in the second winding by switching the electrical current in the first winding on and off. Using this principle, invented electrical generators and electrical motors are frequently working. So, but the disadvantages of the system is that they generate a lot of heat. To avoid this heat generate, used laminated cores and other methods to minimize this effect. Engineers at Midway Steel and Ohio Crankshaft Company drew this knowledge to develop the first surface hardening induction heating system using motor generators. Modern induction heating units utilize the latest in semiconductor technology and digital control system to develop a range of power from 1 kilowatt to many megawatts. So next comes the basic principle. All metal conduct electricity while offering some resistance to the flow of electricity. The resistance to this flow of the current causes a loss in power that shows up the form of heat. This is because according to the law of conservation of energy, the loss is produced by the resistance based upon the basic electrical formula which is P equal to I square R. The practical way of heating is that as the AC current through a copper coil and the part to be heated is placed inside the inductor. As we see, as soon as the AC is supplied to the workpiece, enter the magnetic field, circulating the eddy currents are induced within these parts. And these eddy current flow against the electric resistivity of the metal, generating a precise and localized heat. And this heating occurs with both magnetic and non-magnetic parts and is often referred to as the Joule's effect. Secondarily, addition to the heat produced within the magnetic parts through the hysteresis, internal friction that is created when the magnetic parts pass through the inductor. The factors which we are commonly consider using this induction is that the characteristics of workpiece, metal or plastic, magnetic or non-magnetic, its resistivity, conductor design, its power supply, and the degree of temperature range which is merely required. So there are many methods of induction hardening, and the first one is a single shot hardening. Single shot hardening means the complete hardening zone is first heated and then it is quenched. The hardening can achieved with a multi-turn coil that encircles the entire hardening zone. A single shot is often used in the case where there is no other methods will achieve this desired result. And one of the drawbacks is that the coil design can be extremely complex and involved this process. So the next comes is the transverse hardening. And in transverse hardening system, the workpiece is passed through the induction coil progressively, and following quench spray and rings is utilized. The component is fed through a ring type inductor which is normally a feature of a single turn. The transverse hardening is used extensively in the production of shaft types components such as axle shaft, excavator, bucket pins, steering components, power tool shaft, drive shaft, etc. So major advantages of this induction process is that specific limited local hardening is possible, distortion can be kept very small, hardening times will be shortened, heating process controllable and repeatable, improved product quality, and even more production rate. So the application has numerous applications in the industrial applications, medical applications, and even the workpiece with more length like axles shaft can also be operated. And one of the major disadvantages is that high capital investment is always needed, and each shape of components require inductor to be designed for it. This is comes in difficult in induction hardening. So that's all. Thank you.